All right, let's get started. Today, we actually have a last lecture. It's going to be a short lecture. We're going to talk a little bit about we'll provide some concluding remarks and talk a little bit about how we make the model work in real business. So pretty much in this course, we talked a lot about analytics, and it was mostly retail analytics. We looked into lots of different technical topics, starting from data visualization, regression, classification, clustering and dimensionality reduction, time series analysis, forecasting, recommender systems, experiment design, and agent-based modeling. And we applied them to various use cases. So it's sales forecast, it's customer churn management, segmentation, personalization and recommender systems, A/B testing, and finally simulation. And if you look at pretty much this wheel of various retail analytics topics, we covered almost everything. We probably just didn't do like marketing mix model, but in fact it can be done with simulation as one of the ways of doing it. Overall, as a data scientist, when you develop algorithm, you should realize and understand how it's going to be used. And typically there are two different ways of the using of the algorithms. One is sort of data science and solving problems for decision making. Another one is building your algorithm for production, where end users are the customers who's going to be using the website or buying, purchasing things, or doing anything else, and your algorithm on the back end will provide information. So if we're doing decision makers, it's the goal of those type of algorithms is to help to draw conclusions from data to make decisions. And that could be, purchasing, let's say, the stockpiling, or, forecasting how much stuff to purchase, or setting up logistic chains, et cetera, et cetera. And here, the role would be to design and define, implement metrics, run experiments, run a lot of what-if scenarios, maybe create dashboards, draw conclusions, bring it to business, and let them, based on those conclusions, make business decisions and execute on them. If we're building tools for production, this is usually within this digital world, whether you're working banking or in retail, online websites, online retail services. That would be typically either recommender algorithms, both in banking and retail, or sort of online entertainment, or it could be risk management solutions, things that where you develop algorithm, you train, test, deploy it, and it's being deployed usually by engineers to the production system, and you as a data scientist work here more with engineers, less with business executives. Sort of it's not about making business decisions, it's about building and deploying service. You try through this 10 weeks yourself in the data scientist role, and you realize, I'm sure, that this process is very, very much non-linear. So you start with data understanding, understanding what the data is, then you prepare the data, get rid of all kind of mistakes in data, empty spaces, clean, aggregated. Then you develop a model. You evaluate the model on a historical data, do the train test, find optimal parameter set. And the only thing we haven't done is model deployment. Well, and that's because we are actually in a class, but in real world environment, that's really what you're preparing for. And bunch of tools that you have used so far. We try to introduce you to the tools of the visual programming, visual data flow programming, which is Orange open source tool. There are several other tools like that used in business, like RapidMine or Alteryx. And Azure machine learning is built around it. We actually were planning to use Azure, but due to all these events, it was not available. But the point is, going forward, more and more programming will become visual programming, and so these tools, you will be using them more and more going into the future. And there are some specialized tools also, visual programming tools, but special like NetLogo or AnyLogic that allows you to build simulations. And at the same time, yes, if you're capable, if you know it, if you like it, you can write in pure Python using various libraries. And in terms of visualization, we haven't used like Tableau, Power BI, but these are the tools that you might want to use to visualize your results. Books, well, there are plenty of books. I showed here only the books that we actually on the left-hand side, this is the books that recommended for different lectures. And Data Science for Business remains the core book you want to read. Data Science for Marketing Analytics goes into more into details into some applications for marketing analytics, and the book by Eric Siegel on predictive analytics. This is a pretty good stories of the use of data science in business. And the second column, these are books more in depth if you're interested and want to kind of learn more. And this is applied predictive analytics, statistical learning, elements of statistical learning, data mining, massive data sets. And finally, there are books more on the sides of engineering and programming. One last thought that I want to kind of you to remember is that though data science is extremely cool and brings a lot of value, when you try to use it in a real business settings, the effort is distributed very much non-evenly. And it's typically, goes maybe 10% of overall effort and time going into developing algorithms, probably 20% into building technology based on that algorithm and deploying technology. And like 70% of the time, big part of the time goes on to change management. Change management means changing business processes such a way that they will use your solution. And this 10-20-70 rule, this is a really sort of experimental rule, the one that comes from trying to apply data science in lots of business settings. And so in order to succeed, you do need a champion from the business side that will push the solution forward, that will make sure this change management happens. Otherwise, all the data science effort will really remain just academic exercise. So having said all that, pretty much concluding the course, and we tried to collect some feedback from you guys. Now, fortunately, we didn't get more than 40 responses, but now you'll have a chance, to actually provide your feedback if you want to, or we'll please go and answer onto the Telegram bot, and we'll later on adjust the results. But overall, if you look at the questions we have asked, you sort of the lecture material majority find sort of the difficulty at sort of average, with almost Gaussian distribution to the left to the right, which is probably good. Lectures quite interesting, well explained. There is some differences in between lecture and seminar, which even by design, because we wanted you not only to practice what's been done in the lecture during the seminar, but also learn some new material. If we look at the seminars, there is also the same kind of distribution with sort of average difficulty of the seminars. Interest and the explanation are pretty good. The one area for concern for us, and we'll probably sort of have to fix that for the future classes, is instructions for the homework, how to actually provide better and cleaner instructions for the homework. And finally, sort of also quite interesting, that majority of the class and this sort of the ratio increasing every year, doing homeworks in Python. Then there is some in Orange and Excel, and even less in R. Would be really interesting to see this for the entire class. And the questions were sort of asked and answered. So this is really all I wanted to say to close the class, to close this data science for business class. I want to open right now for questions, for discussions. If you have any questions, Anwar is also with us, so we can try to answer if you have any questions. And with that, please go ahead. All right. Do you have any questions, guys?
Is it planned to create like the second block of this course for continuing study for next year, maybe, or I don't know, next years?
We were thinking about doing sort of, was an introductory, thinking about doing more advanced version, where we will look into, I mean, to be fair, the algorithm that we looked into in this course, there were kind of from last 10 years of the development of data science, right? And they're maybe new in 2010, but now they're commodity, right, in some sense. And today, a lot of problems being solved through deep neural networks and sort of various more advanced algorithms. So we're thinking about building a course based around that, but there are certain technical requirements that are needed for that to be done. So short answer, yes, we're thinking about it, not offered yet.
Thank you.
Anything else, guys? All right, if there is no more questions, then the last comment is about the grades. We're collecting all the grades, so the grading scheme will be based, of course, on your total cumulative grade from all the homeworks. There are some technical things we need to do on our side, some duplicated emails, some sort of lost homeworks, but we should be done shortly. And we do not have an exam. We don't have an exam for this course, but we'll, set up time next 2 weeks after we announce grades to, have a feedback and discussion on the grades.
There is a question in the chat from Anna Glukhova.
Yes, I have only one organizational question, whether some additional bonus homework can be added just for those who wants to improve the mark. Oh, interesting question. Look, I hadn't thought about it. Let's us, Anbar and I will discuss it and come back. We just want to make sure, we kind of treat everything as fairly, right? And added additional homework is an interesting question. We'll get back to you on this. All right. Okay, guys. Well, thank you very much. Again, thank you for participating. We'll stay in touch. We'll get back on the grades and then have a discussion. All right.
Just to add up. So I'm still here. So if you have any questions